one more thing. Whoops. Test. Test. Alright, good enough. Now let's get to it. Okay. Cool. Uh, okay. Let's do these exercises. And then let's go to the next section. It's kind of, this is a lot more than I thought. So I may have to do this tomorrow as well. Alright, add a level of life to the sphere. Sure. Each time the sphere collides with a cube. Alright. Fair enough. I think I can do that. So, what is it here? Is it in this one? The on collision? On trigger enter? On collision? Oh yeah, I can just delete this. And then I'm gonna do just private int lives, I guess. And then we'll just do, actually, I can just set that to something. And then I'll do lives plus equal, oh, sorry, plus minus, or minus equal 1. Okay, and then I do if lives equals 0, then I print oh, actually no. Then I do this. Then I do destroy game object. And then you can't play the game anymore. And that should be good, I think. Unless something went terribly wrong. It should be in this script, correct? Public float, public int. Oh. Do I need it to be float? Does it have to be a float? Or can it has to be public? Okay. It has to be public, I'm guessing. Yeah, alright. So let's just do 10. let's just do 10 for now. And then, let's just make all of these. Oh, actually, this is still here. So yeah, let's just do this. Ooh, this should work if, yep. Nice. All right, I did it. Let me just think. Coroutine, IEnumerator. That's what we did last time. All right, boom. We did it. Modify the coroutine and add what is necessary so that randomly not only the game objects created are cubes but also capsules. Okay. I actually don't know how to do this really. So this might suck a little bit. So if I do erupt. Okay, stone. Oh wait, I can actually, or can I? Randomly? Okay, wait. If I do random dot int or random dot integer, I don't know. Okay, yeah, let me do. So, I mean, I know what to do here. So I create a capsule and then I reset that. I don't know why is there not a button for reset? And then I'm going to make a material. And actually, I'm going to change this to red. So that means all of these should change. No? Oh, they do, but these are just cubes. Oh. Oh, never mind. Uh, I didn't read that these were planes. All right. So now we do. Yeah, let me just like clean this up a little bit. And actually, no. No, let me undo that. Let me move these into the main plane here. And then let me just actually. Wait, if I drag this in here, then it just automatically becomes a prefab. Got it. Got it. So now I can delete this. And then uh, let me rename this to red. Sure. And then bam. And then the block is also red, but it's not represented here for some reason. Okay, and this is stone. Where's stone? Oh, no. Stone. Block and capsule? Can I add more than one, please? No? Can I not add more than one? Okay, this is gonna be a little tricky. Okay, wait. So if we open up this physics move script, there's a tag, cube. Okay, wait. Can I just do... Instead of stone, can I just do... No, no, I can't. Okay, wait. Stone. Game object stone. Hmm. I don't know what I'm doing. Cube. Game object dot tag equals cube. Okay, hold up. Hold up. I don't know why I keep alt tabbing. It's right there. Throw stone. So this isn't... Let me just... let me just keep it the same for now. And then I just make a new one. Um, I don't know. Or rock. Sure. Rock. So... I'm gonna add an if statement here. If random dot integer number. Okay, is there a lowercase random? Random dot int float. Okay, random numbers in C sharp. Random dot next. Oh, random dot next int. Okay, so random dot next. Is this even supported, bro? Is this even supported? Oh, RDN? RDN? Okay. Wait. Okay. Nice. All right. Integer or floats. Nice. All right. Random dot. Did I seriously already forget range? Random dot range. It's right there. 0, comma 1. And then we do a little bit of a, ooh, and then, oh yeah. If random dot range equals 0, sure, I guess we can do this. And then, sure. Else, and then we just copy this, and then we do rock. We do. How did I do this? I messed up my cursor. How to change cursor back in Visual Studio. Okay, insert. But I didn't press insert. I I always forget that. Okay. Rock. Yep, that should work. Now we just have to define rock. Um, what is going on? Thank you. Prefabs. Alright, we just drag this in here. And let me make sure I did this correctly. Actually, I can just test it. I can just test it. Easy. Okay. It didn't work. And now I can test it. And it should work. Okay. I forgot. I forgot. This doesn't have physics applied to it. This doesn't have a rigid body. F. And what is this? Row? Also, erupt physics up start. Um, yeah, yeah, I forgot I have to add a rigid body to this. But I forgot how to do that. So, how do I add a rigid body? No. No. Um, component, rigid body. Thank you. Now let me just make sure all of these are the same. That's fine. Position, that doesn't make a single difference. Discrete physics upstart. Okay, yeah. I do need to put this on. Okay. I don't know what I'm doing. I don't know what I'm doing. Physics upstart. And then, let's see, what do I do now? Should it work now? Yes. Yay. And I just run into this. Nice. Okay, I feel like there's an easier way to do this, honestly. Um, if random dot range, is there? Um, random dot range. I'm thinking of a true false thing, like if. No, no, that's it. That's it. Actually, never mind. Yay, I did it. I did it all by myself. Now let me make sure my tabs sync it. Thank you. Nice. Um, this, I don't want that there, honestly. You know, let me just, no, no, I don't need it. I don't need it there. Did I actually do everything? I feel like I'm forgetting something. Um, so all I needed to do was add a rigid body and then drag the thing in and then add the physics upstart script, and that was it. Dang. Yeah, I guess that was easier than I thought, maybe? Oh. Oh! Those are actually automatically disappearing. What? Oh. Hold up, bro. Oh. I see. That's very convenient. Alright, let's continue. We're going to develop a complete example now in which we are going to create several scenes in game with everything we have learned and which is easy to expand and that can end up being a game to be proud of. Alright, nice. You'll need to download 3 files that we'll use in the development of the project. Download these 3 files and make sure you have them on hand when you follow the videos. Okay. Sure. Um, I guess. Thanks. Wow, this is actually like the longest section. Oh. Oh. Okay. Well, never mind. It's actually not as long as I thought. But whatever. Okay. We have these on file?
With this video, we start a collection of videos, which objective is going to be to create a complete first example.
I mean, if these are 15 minutes each, that's gonna take a
And we are
little
going to
longer
create
than I
our
thought, yeah.
first little game. And in order to do that, of course, we are going to be using all the knowledge we already have, and we are going, of course, to see new things. So the very first thing I'm going to do is to create this new project. I'm going to call it Destroy Stones, okay?
Sure, you know what, I'll make I'll make a new one too. And then, bam. And let me open this. Okay, great. You can see my name, yay. New project, 3D. Third person. Oh, this is like super cool, actually. What the heck? It like has a game for you already. Alright, that's very cool. I'm probably gonna use that later. FPS micro game. Oh, that's cool too. That is cool too. Um, I forgot what was I gonna make? There was some game that, oh, yeah, I was gonna make some 2D game, but I feel like I thought about making some FPS game. I don't remember. Whatever. Karting, micro game. Okay, 2D platformer. Sure, a Lego micro game. 3D mobile, 2D mobile. Oh. Oh, this is like... This would like crash my computer, I'm guessing. First person. I see. I see, this isn't the same as the FPS. So these are just like templates. Well, these ones, and then this is not really a template. This is kind of just a whatchamacallit. It's just like a showcase, I guess. So these are not. Oh, I opened this one before. The Universal Render Pipeline Template. Okay, 3D sample scene. Oh, this one is also one that would crash my computer. So, what is this? Yeah, uh, templates are core, and then I guess I'll try these later, probably. I don't know if I'll do that on stream, but whatever. All right, 3D. Let's do um let's just do edX final project. Sure, why not? And boom buddy, boom buddy, boom bang. Bing bong bang boom buddy. And also I have to add these to the correct folders. Main loop.cs. What is CS? Oh my gosh. It's actually going to take a little while for this to load. So documents, Unity, where is it? Unity. Where the heck is it, bro? I don't even know. Okay, let me just open this. Open Unity Hub. And then if I do documents, it is in documents. Unity, okay, Unity is just way down at the bottom. Got it. So if I just drag these right in, what is this stone.fbx? He'll tell me. He'll tell me.
And of course it's going to be 3D, and we are not going to need any extra element from Unity. Okay, so in this project, one of the things we are going to do for the very first time is to have different scenes. So as you are going to see, we are going to create different scenes, and we are going to learn
Oh,
how
we're
to
gonna
jump
make
from one
different
scene to the other.
scenes, bro.
These different scenes are going to be important because they are going to be the different screens we are going to have in our game. So we are going to have an initial screen from which we will be able to go to play and to start the second scene, which is going to be the game itself. And when we finish with the game, we are going to have a final scene with a kind of summary, okay? And then we will be able to jump back to the first scene. So this is going to be very common in Unity, to divide the game or interactive application into a collection of scenes. The other thing important in this project is that we are going to be using these two resources, main loop, CS, which is going to be the main code of our project. So in order to avoid to typing it, okay? And the second resource we are going to be using is this stone,
Okay.
FBX, which is going to be the shape, the model of the stones we are going to be using in our project. This format, FBX, is the recommended format whenever you want to import in Unity. Unity allows other formats, of course, but it is going to be very common to export from the 3D softwares in this format. And this format allows us to export not only the models themselves, but also the animations. Something is going to be very useful whenever we want to import in Unity these kinds of elements. So the very first thing we are going to do right now in Unity, as usual, is to create this collection of folders we normally create. In our case, first of all, what I'm going to do is to change the name of this default scene. I'm going to change it to Stone Game. Okay?
Sure.
Reload.
Stone game. You use camel case. Alright. I'm not done yet, bro. Thank you.
So this is going to be the name of the scene. The name of the scenes are important because, as you're going to see, we are going to use the name in order to jump from one scene to the other. So now, yes, we are going to create the collection of folders. So we can create a folder for the scripts. We can create a folder for the prefabs.
Okay.
Remember that this folder structure is up to you. You can create as many folders as you want, and of course the names of the folders are also up to you. I'm going to create one for the materials.
Okay, here's my question. Why aren't those folders in there automatically? That's my real question. Uh, is there like a shortcut for this? Is there like a shortcut for creating folders? What is this? Prefabs? Materials? Scripts?
And also because I have a model, well, I think it's convenient to have a folder for the models. So this is a very common structure
Sure.
whenever you start a new project, okay? So it's something very interesting when you start a project. Okay, the very first thing
I'm sure I can change the default. Like I can change the default folders. You get it.
do is to import this stone model, okay? It is outside, it is here. So in order to do that, what I'm going to do is to double click on models, and now I'm going to drag and drop, okay? To drag and drop. Okay,
Whoa,
so as you can
okay. It's a lot of things. It's actually a lot. I thought it was just like one thing. But all right. Oh, that is interesting. It doesn't move it. It just um copies it. Okay. I'll delete it then. Okay. Cool.
see, there's a little arrow, okay, next to the model, okay?
But I
So as a
guess it
matter
is
of fact, you
just
can see
one thing.
that we have several things inside this stone. We are mainly interested in this, okay, in the shape of the stone, okay? Well, I have been using this model before, so I know that I'm going to have a problem with it. The scale of this model is not very large, okay, it's very small. So I'm going to change that, okay? I'm going to select the stone, okay? And in the inspector, you're going to see that we have several tabs. Select the model, and here you have the scale factor. Whenever you import something and you drag and drop this something into your scene, and you see that the scale of the element is not the appropriate one, you can change this scale factor. As a matter of fact, I know that 300 is going to work very well for the game I want to develop, okay? So I'm going to apply. So now I can
Why
drag and
was
drop
it so gosh dang
our
small?
stone in the scene. So I'm going to select the shape, okay? I'm going to drag and drop. And as you're going to see, here I have, okay, a first
Okay, that's
instance
very
of my
large. Never
stone.
mind.
The central element of my game is going to be this one, okay, these stones. The objective of the game is going to be to throw these stones from the bottom to the top, okay, using the gravity, of course. And the mission of the player is going to be to destroy these stones by clicking them, okay? Okay, so the reason because it's pink is because this stone has no material yet, so we have to create the materials. Of course, I'm going to be using the physics engine. So in order to use the physics engine for this stone, we need two very important elements. One, as you know, is the rigid body. So I'm going to add a rigid body. By adding a rigid body, this means that we will be able to apply forces into this stone, and the physics engine is going to take care about the movement of the stones. And of course, I'm going to leave the gravity activated, okay?
I like how his mouse gets bigger. I don't know what setting that is, but Poggers. Yeah, let me remove that. Sure. 300. Okay. Okay. Why is there a plane? And it has a camera. It has everything. Okay. Sure. Uh, this does not look like what the guy had.
We know
So let me
the
go back.
stone
Convert units.
in the stones from the bottom to the top, okay, using the gravity, of course. And the mission of
Okay.
apply forces into this stone, and the physics engine is going to take care about the movement of the stones. And of course, I'm going to leave the gravity activated, okay?
Sure. I'll add it to just the stone. Just the cube. Right? I don't need I don't need anything else. To, yeah, I don't need anything else to get the rigid body, correct?
The other thing I need is a collider if we want to detect collisions. And this is going to be the case. Collisions are going to be interesting because the stones, the different instances of the stones, could eventually collide between them. And this is going to be fantastic. And also we are going to need the collider for something also important. If you want that the user could be able to click and to detect that it is clicking on a specific object in the screen, the collider is going to be also necessary. So we go to component, to physics, and now we have to decide what collider we are going to use. Well, we have several possibilities here. We could use the mesh collider, which means that we will be trying to use the same shape from the geometry. However, it is quite common to try to use a simple collider, okay? Because this makes the calculation of the intersections much more efficient, okay? So it's in this case, I'm going to use, as you're going to see, a sphere collider. Okay?
Aha!
So as you can see, the sphere collider is...
Aha! Nice. I'm so good. I'm so hacking good. So... Sorry, cube?
is well quite good, okay, for the shape of the stone. Of course, there's a little error, okay, a little areas where we don't have stone, but as you're going to see, the result is going to be very good, okay. So, and the sphere collider is, without any doubt, the most efficient collider because it's very easy for the physics engine to detect intersections between spheres, okay.
Oh, or can I not adjust this? Can I not adjust this? Whatever.
So, okay, so now we have this game object prepared. The first thing I'm going to do is to change the name. I'm going to call it stone. So it is ready in order to create the prefab, okay? So I go to the prefab folder, and as a matter of fact, I'm not going to create only one prefab. I'm going to create 3 prefabs. And the reason is because we are going to have these 3 prefabs with different materials. This is going to make my game much more interesting from the visual point of view. I'm going to be, in a random way, creating instances of these stones from these 3 prefabs. So using 3 different materials, we are going to have a much more interesting visual effect, okay? So
Okay. So I can adjust this. Yes, but okay. Yeah, this is like way too big. Okay, maybe it's not. Never mind. Uh, yeah. Yeah, you know what? That's fine. That's fine. Let's test it out. Okay, the plane doesn't have a collider.
So
Right?
remember, to create a prefab means that we have to drag and drop a GIMP object into the prefab folder. Okay, so here we have the first prefab. I'm going to change the name to Stone1. Okay, and then I'm going to drag and drop again.
Gosh, dang, bro. These are some really creative names. So he renamed this cube to stone? I'll just do rock, rock.
Okay, well, in this case, Unity is asking if the new prefab is going to be an original prefab or is going to be a variant of the previous one. And we are going to say yes, the original prefab, okay? Because they are going to be different. So we are going to change the name to Stone2, and I'm going to do exactly the same with the third prefab, original prefab, and we are going to change the name to Stone3. Okay, so we are going to have these three stones, Stone 1, 2.
Now let me actually rename this to capital R rock.
And 3, these three prefabs. So we are creating three different prefabs because they are going to have three different materials. So let's create the materials. So with the right button, remember, we are going to create the first material. I'm going to call it Stone 1. The second material, I'm going to call it Stone 2. And
Okay, let me look up color wheel. Color wheel. It's red. Oh, red, green, blue. Okay, I don't know why I thought it was something different.
the third material, we are going to call it Stone 3. Okay, that's it. So, well, the only thing I'm going to do right now is to change the color, okay? But it's up to you, of course, to find.
Children of a prefab instance cannot be deleted. Okay. Children of a prefab instance. Unpack the prefab instance. Okay. Okay. I'm fine with that, I guess. Oh, actually, that's fine. And then we add. And then we add another one. Original. And then original.
To look for different textures you can use in order to make this game much more beautiful, okay? But right now, the only thing I'm going to do is to change the color. In this first one, I'm going to use something dark red or something like that. For the second one, I'm going to use dark green.
Okay. Create. Material. Where are those again? Thank you. Yeah, I'll just do simple. Just do very simple names here. And then I forgot where it was. Thank you. I forgot to red, green, blue. Very nice. Super crazy. Crazy. dark. You know what? Dark is fine. Let's choose 0. Yeah. There's the RGB right there. Let's just hacking do it, bro. Okay, that's red. I don't know how I like messed that one up. But I do have to say that is a very bright green. Okay, blue, green, red. Bam. We're doing it. Okay, then we got red rock. Blue rock. I know, very creative names. Green rock. I think they're a little bit more creative than the names that the guy the names of his stones. So Bing, so get smashed, nerd. How do I do this? Add component. Material. Material? No. Can I edit? Select material? From here? I don't remember which one this is. Blue. Okay. What the heck? Um, can I just like, bam? Oh, I can? I guess. And then I can actually, I don't know what I'm doing. Materials. And actually, I can do this. Open prefab. This is green rock? Boom. You're now green. Congrats. This is red rock? Boom, you're now red. Congrats. If I pull these out, they should be the right color. Yes.
And for the third one, I'm going to use, for example, dark gray, which is in this column. The grays are in this column. So now we have the three materials. Now we have to assign these three materials to here. If you have apps, so in order to do that, I select the first stone, okay? And when I have the first stone selected, I go to materials and material and
Boggers.
into a dynamic way. So we don't need anything in our scene because we are going to instantiate these stones in a dynamic way. So we don't need anything in our scene. Okay, so we are going to remove it. So now is everything prepared to start
Boggers.
working with the game and with the logic of the game.
Okay. Cool, we just clear this? Like, do we not want this plane here at all? Sure. Yeah, let me just delete that completely.
We are going to see now the most important element of the game, the script,
cool.
the main script. We are going to call it main loop. The mission of this script is going to control all the game, so it's going to be very, very important.
Sub-rip? What is that? I've never seen that. Oh, transcripts. Never mind. It's just a transcript.
It is not a complex script, but it is a bit long. So this is the reason.
We're gonna see now the most important element of the game, the script, the main script. We're going to call it main loop. The mission of the script is to control all the game. Whoa. It is the mission of this script is going to, okay, the mission of the script is to control the game. Wow. One might even say purpose of the script. Crazy.
Because we are not going to type it, okay? So what we are going to do is to go to the scripts folder, and we are going to import it from outside.
Sure. Okay, main loop.cs, right? Is that the correct one? Yes. Poggers, I'm a programmer.
Okay, so we are going to double click on main loop, and we are going to see in our code editor this script. Okay, this is the script. As you can see, it's not a very long script, but it has some very interesting elements.
Not super long.
This is going to be the main loop, the main script of our game. So it's going to control, as you are going to see, everything in our little game. So the mission of this script is going to be to instantiate these stones and to throw these stones from the bottom of the screen to the top of the screen. Okay, how we are going to do that? Well, first let's pay attention to the different attributes, variables we have defined inside our main loop script. The first one is going to be very important, stones, and it is going to be public. And it is going to be of the type game object, but not only one game object, it's going to be an array of game objects. As a matter of fact, it is going to be the array of 3 game objects. Remember that we have created 3 prefabs. So instead of having just here a unique prefab, we are going to have an array with 3 prefabs, which components are going to be 0, 1, and 2, okay? The reason is because we are going to randomly generate an object from one of these 3 prefabs. So with that, we are going to generate random stones with random materials. And this is going to be visually very effective. The other
it's going to be visually. It's going to be so effective visually. It's going to be so interesting visually. Like, okay, whatever.
Variables, I made all public so they can be edited in the editor. The other variables are going to give us different values and ranges of values for the creation of these stones. The first one is going to be torque. Torque is going to be another kind of force. So instead of a linear force, torque is going to be used in order to create what we call a torque force, which is a force that is going to make our object to rotate, okay? So we are going to make it spin somehow, okay? As you can see now, we have mean anti-gravity and max anti-gravity, and we have a range of values from 20 to 40. And this is going to be common in all the next variables. And the reason is because I'm going to generate random numbers from this minimum to this maximum in order to give our game some kind of prediction, okay? So to be able to not predict too much what is going to happen with the next stone.
Unpredictability.
Okay? So this is going to be very important to work also with some random elements. So mean anti-gravity is going to be 20, max anti-gravity is going to be 40. So remember that the gravity is going to be minus 9.81, okay? So it has to be something greater than 10, okay? So because this is going to be the force we are going to use in order to throw our stone from the bottom. And eventually the gravity is going to make our stone to fall down, okay? The mean lateral force and max lateral force is because we are going to throw the stones from the bottom, but we want them to have some kind of left or right tendency, okay? So we are going to also use a lateral force in order to push the stone to the left or to the right. A negative value means that it is going to have, the stone is going to go to the left. A positive value is going to make our stone to go to the right. We are also going to create one stone, and after this stone, we are going to wait a time in order to create the next one. And even this time is going to be random, from 1 to 3 seconds, okay? So again, in order to try to provide the game some very interesting behavior, random behavior. The same thing with the X, okay? The X is going to be in which part of the screen, left or right, the stone is going to be created, okay? So 0 is going to mean that the stone is going to be created in the middle, but minus 30 plus 30 is going to make the stone to be created a bit to the left or a bit to the right. And also we are going to also work with the Z, which means that we are going to create stones that are going to be closer to the camera or less closer to the camera, so we are going to see them smaller or bigger, okay? So this is going to be also very interesting. Now we have a Boolean variable that is going to be true. By default, this is going to be the loop. This infinite loop we are going to be using when we want to throw the stones. And of course, we are going to use the rigid body, okay?
Private bool enables stones equals true? Why would you need that? I guess I'm gonna find out, but it's kind of seems like you wouldn't ever need that.
So as you can see now, the structure of the main loop is going to be very similar to a previous example. We are going to use a coroutine, and inside this coroutine we are going to generate the stones, and we are going to wait
Unless it's gonna change, right? You get it.
some time in order to create the next stone. So this coroutine is exactly the same coroutine we were using in the previous example, so you must be able to understand how it works. So the very first thing we are going to do is to wait a couple of seconds. It's always a good idea to wait a bit, okay, when the stage with the level starts, to wait a bit in order to give time to the user to be prepared. The player needs some time. After that, as you can see, we have the while loop. And remember that this enable stones is true by default, so we are going to have a kind of infinite loop. And we are going to do something we already know. We are going to instantiate, okay? We are going to create a new game object. But in this case, instead of from a unique prefab,
Enable stones. It's
we are using
literally
stones, which is
nowhere
an array
else
of
on the gosh dang script.
three
Okay.
prefabs, 0, 1, and 2. Which one is the one we are going to generate? Well, we are going to create a random number. And the random number we are going to create is from 0 to 3. 3 not included, okay? So this means that the real number is going to be created is going to be 0, 1, or 2. So we are going to, in instantiate, to create a game object, okay? That it is going to be created from one of the three prefabs randomly. And we are going to store this variable in stone, because instantiate returns the game object we have just created. And we store this information into stone because we are going to do things with stone. The first thing we are going to do is to change the position. And in order to do that, we are going to
Wait, the length is 3. Yes.
use some
Okay,
of the
never mind.
variables we have defined before, because we are going to use also some random numbers. So in the x component, we are going to generate a random number from min x max x. So again, in order to provide some kind of variability to our game. In the y-axis, this is going to be very simple. We are going to create the stone below the screen. Okay, this is going to be very important. So it's going to be, when we create the stone, it's not going to be visible to the player. Okay, and for the z, again, we are going to generate a random number between min z, max z. Okay, so this is going to make closer, or let's say bigger, the stone, or smaller. Okay, working with the z component, the z axis. Okay.
No. What? Bigger or smaller? Oh, so yeah, closer
And again,
or
we
farther.
are going
Sure.
to generate a random rotation. So the position of the stone is going to be random in the 3 axes. Okay, so after that, what we do is from stone, we get the rigid body. And we get the rigid body because we are going to do now something very important, to add forces to our stone. The main force is going to be a vertical force, but as you're going to see, we are going to add other forces in order to make the creation of these stones much more interesting. The first 3 elements is something new, is instead of add force, add torque, which is this kind of angular force, okay? So we are going to make our stone to rotate, to spin around one of the axes. So we are going to use vector 3 up, right and forward. Up is the vertical, the y-axis, right is the x-axis, and forward is the z-axis. So we are going to make our stone to rotate around the 3 axes, okay? And we multiply by torque, which is now 5. We could also use some random numbers here, okay? But in this case, I think it's just 5. And of course, the kind of force we are going to use is impulse, because we want from the very beginning to have this angular velocity, okay? So it's not a constant force. Now it comes the most important of the forces. This is the most important of the forces, the one responsible for throwing up the stone. And in this case, of course, we are using the vector 3 up. This vector is 0, 1, 0, okay? And now we are going to multiply this 0, 1, 0, okay, with a number from min anti-gravity to max anti-gravity. So this force is going to be from 20 to 40, okay? So, okay, again, in a random way. And of course, impulse, okay? So we want to kick, okay? We want to have from the very first moment this velocity in our vertical movement. And finally, we want to make our stone to have a tendency to go to the right or to the left, okay? In order to don't have, of course, the stones only in the middle of the screen. So in order to do that, we use vector 3 right, which is the 1, 0, 0 vector, and we are going to generate a random number from min lateral force to max lateral force, which means that we are going to generate a number from minus 15 to 15. If it is negative, the final number generated, the stone is going to go to the left. If the number generated is positive, the stone is going to go to the right. And again, force impulse, okay? The force of the type impulse, okay, again. And as we did in a previous example, we are going to wait for a specific amount of seconds. In this case, instead of a fixed number of seconds, we are going to generate a random number again between 1 and 3 seconds. So this is going to give, again, some random behavior to our game, and this is going to be very interesting and very funny, okay, for the player, okay?
Very
so
funny.
This is the main script of our game, and the main part.
Oh my gosh, bro, I have hair.
In the next video, we are
There's a hair in front of my eye. Where is it? Come on. Come on, please.
going to see how
Whatever.
we can put this script into action, which is the object that is going to have this main loop, and how we can have even a first initial feeling of our game.
This is not taking quite as long as I thought it would. Also, I guess you're going to be using random.range a lot. Like, all the time, basically.
In the previous video, we have seen this main loop script. Now it's time to see this script in action. Okay, so we are going to go back to Unity. And the first thing we have to decide is which is going to be the object that is going to have this main loop script. Remember that the mission of this main loop script is to instantiate stones, okay? So we have basically two options. We can create an empty game object, and this game object is going to just be there in order to have the script main loop and only this mission. Or we can use a game object in the scene that remains active during all the execution of the scene. A very good example is the main camera. So both possibilities are correct and fantastic, okay? So in our case, what we are going to do is just that.
Wow, they're both really fantastic.
Into the main camera, okay? So as you can see, I have decided to put the main loop into the main camera. The other option is to create an empty game object, and to attach this script to this game object. The result is going to be exactly the same. Okay, so as you know, in this main loop, we have already some public information. One of them is the array of game objects, the array of prefabs. So remember that we have 3 prefabs. So don't forget that they start with none, and we have to initialize them in the editor. So this is what I'm going to do right now. I'm going to go to the prefabs folder, and I'm going to drag and drop the stone 1 into the element 0, stone 2 into the element 1, and stone 3 into the element 2. Okay. So remember that the script now is going to generate random numbers in order to create a random stone with the 3 different materials we have used, okay? All the attributes are public, but we are going to leave the original values.
Okay. So let me just do this. Then let me just do this. Oh, it like doesn't matter because I didn't number them. Oh, okay, perfect.
Okay, now we have to adjust the camera, okay? We need to adjust a bit the camera in order to have a very interesting effect.
There you go.
So we are going to
think I
select the
did
camera,
it. I think
and we are
gone
going to
now.
change some parameters in the camera. So instead of the position in -10, we are going to make it far away, -120. And the other thing we are going to change is that, well, we don't need the far plane to 1000. We can keep it in 200. With 1000 is going to work as well, but with 200 it's enough. And the other thing we are going to change is that, well, we don't need the far plane to 1000. We can keep it in 200. With 1000 is going to work as well, but with 200 it's enough. And something also very important is the field of view, okay? So the field of view is too high, so I'm going to change it to 25, okay?
Planes?
Of course, you can experiment with these values once the game is running, so you can see the effect of them, okay? So with that, I think we can run the game and we can see the effect. So
what is clipping planes? Wait, can I? Oh, move to view, so align with view. No. Okay, so if I do align with view, then it's right there. Got it. Clipping planes. 200. I don't understand what's going on, really. Okay, can I see it? Can I see what's going on, please? No? Why is it not showing it now? Okay, that's the field of view, as to be expected. Um, and sure, 25. But what is this? What is this? 200? Oh. Oh. That's what that is. It's like how far it can see, I guess. If I could just drag this, it's like the distance. It's like the distance that I can see. I'm guessing, but like, is it, does it actually restrict? Like, it still sees everything though. Whatever, I'll look it up later.
You can see what is going to be the effect of the current situation of the game. So as you can see, okay, as you can see, we start having some random stones with random colors, okay, as you can see, using the random parameters we have created, okay. Well, one of the things we are seeing is that the velocity of the stones is not too much, okay, so it's going to be very easy for the user to destroy by touching all the stones, okay. So one way we have in order to change how fast our game runs is what I'm going to do now, okay? One very interesting way of doing that is going to project settings, okay? And in the project settings, I'm going to go to time, okay? To time. Let's open this, okay? And there's a parameter, a very
What?
interesting parameter here. It is called time scale. By default is 1, which means that 1 second of the real world, of the reality, is going to be 1 second in the game. But we can
Oh my gosh, dude. 1 second of the real world, 1 second of the reality. This guy is freaking cracked out, I swear. It's so funny the way he says things. That's like so existential,
change
but
this. We
whatever.
can put, for example, a value greater than 1, for example,
It's
3.
like you die in the
This means
game,
that
you die in real life. Yeah.
in 1 second of the reality, we are going to have 3 seconds in the game. Okay, so the game is going to, in 1 second of the reality, you are going to see 3 seconds of the game. So the effect is going to be that you are making your physics engine and everything related with time much faster. Okay, if you put a value less than 1, the effect is going to be the opposite. You are going to slow down the game. Okay, so this is a way we have in order to solve this kind of problems in a very
If you put it less than 1, then it'll go back in time.
easy way to change the time scale. In this case, I'm going to leave it into
But
3, okay? And let's see now the effect. Okay, this is much better. Now, if I have to destroy the stones, this is going to become much more interesting, okay? This time scale can be accessible also from your scripts, so you can change the velocity of the stones in an interactive way. Okay, you can change this time scale during the execution of the game, so you can increase the speedness of everything, okay? So now what we are going to try is to really destroy the stones, and this is something we are going to achieve in the collection of next videos.
okay. Do I want that? Um, what did you project settings? Build settings. Is it build settings? No. No. Nope, that's not it. Get me out. Project settings. Let's just do 2 because that seemed a little fast for me. You know what? 3, sure. Sure, 3. Why not? Okay, did I make the collider a good size? Yeah. Yeah, you know what? That's fine. That's fine.
If we run again, we are going to see that we are going to start creating stones, okay? But we don't destroy them, okay? So this means that the list of active stones is going to grow and grow and grow. And eventually, of course, we are going to have memory problems and performance problems. So we have to avoid this. And in order to do that, what we are going to do is something we did in a previous example. We are going to create another script. In this case, I'm going to call it stone. Okay. And this script, I'm going to attach this script to the 3 prefabs, okay, of stone. So in order to control this, I'm going to create a constant. It's always a good practice to create the things as constants. I'm going to call it, for example, edi, and a good value is going to be minus 30. So what I'm going to do is, if the stone falls down and it is beyond this minus 30, what we are going to do is to destroy the stone. It's not
Const. What is const? Is that like final?
going to be visible.
Const in C. Oh. Okay. Const versus final? Makes the variable constant from compile time only. So const is better? Final means single assignment. A final variable or field must have an initializer. Once assigned a field, a final variable's value cannot be changed. Final modifies variables. Oh. Const modifies values. Got it. Cool. You saw my email? I love how they do that. Final and C. So, oh, okay. Const isn't in C. Got it. Okay, I'm just making sure my tabs are still there,
for
so
the player, and it's
they're not like deleted off my computer.
not going to be readable for the player, so we are going to destroy it, okay? So,
You know, I'm a little bit paranoid. I don't want to have to go find my window or find my tabs again. So
this condition is going, of course, to be inside the update, so we can get access to the transform position, the y value, and if it is less than this I die, then, as you know, we can destroy game object. Okay, so we are destroying the game object to which this script is attached to. Okay, so that's it. Okay, this is the script. Okay, this is the script. We are going to save it. Okay, and
that's it. Stone. Why is this under stone? I'm so confused.
now remember, we don't have only one prefab. We have three prefabs. So we go.
So I'll just do what he wants, I guess. So stone, sorry, script, stone, what is it? Private const float. Oh, why die? Why die? Why would you die, bro? That's so dumb. Why did you die?
One prefab, save it. Okay.
What did he do? Negative 30? Can't I just like do this? Like, why do I have to do 0.0? Like, it's gonna change it to a float anyway. Right? Was it game object dot position? Or is it transform? It's transform. Transform dot position dot y is less than y die. Destroy? Hello? Destroy? What in the world? Sure.
And now, remember, we don't have only one prefab, we have three prefabs. So we go to the prefabs folder, and we have to be sure that we assign this script to the three prefabs. So we select the first one, okay? With double click or open prefab, we can get access to the information of this prefab. And here we can go to add component, and we can go to scripts and to select.
Sure. Did that go on that? Nice. Cool. Yeah, let me just do this. And that should be good.
Stone, okay? So now we can go back, okay? And stone number 2 with double click, okay? Or open prefab. We can go to add component and again, scripts and stone, okay? And for the third one, okay, again the same process, double click and scripts, we can select stone, okay? That's it, okay? So we can go back. Okay, so now we have in the three prefabs, we have the script stone. So this means that now if I run, we are not going to instantiate only the stones, but we are also going to destroy them, as you can see, okay? So if we see the hierarchy view, we can see that, yes, we are creating new stones, but they are also automatically destroyed when they reach a specific value, -30, in the y-axis. Okay, so this can also be in the same view. Okay, so in the same view, you can see, okay, that, okay, these stones are created, and of course they are destroyed.
Okay, bro. Oh my
And
gosh.
here, again, this is what the player is going to see, and this is what it's going on really. Okay, so the stones, when they reach a specific value, they are destroyed.
Nice. Let me actually double check that it's actually working. Nice. Nice.
We are going now to add an essential functionality to our game. We are going to try now to touch the stones and to destroy them, okay? Which is probably the most important thing, okay? So it is the main objective of the game, to be able to destroy these stones, okay? How are we going to do that? Okay, we are going to do that by changing our script stone. So what we are going to do here is to use a method. It is called onMouseDown, okay? This method onMouseDown is going to be called if the user, the player, touches with the mouse and the left button the object. And we are going to have also the same behavior in a mobile device with the screen, touching the screen, or if we have a PC with a touchable screen as well, okay? So this method is called onMouseDown. Okay, this is the method we are going to use for this objective. onMouseDown, what does is internally Unity is going to use a technique, it is called ray casting. So Unity is going to generate a ray from the position of the mouse or our finger in a touchable screen, and is going to try to calculate the intersection of this ray with the elements, the game objects of the scene. And if there is an intersection or several intersection, the object that it is going to be, the one is going to receive the onMouseDown.
I guess we don't need to check every frame for it. Okay, update. Update is called once per frame. Okay, wouldn't a better way to do that destroy function? Or a method? Whatever. Like method, function, whatever. Yeah, you got it. Actually, are functions and methods the same? Hold up. That's like a shower thought. Let's go. Are functions and methods the same? A method doesn't have to be associated with an object. What about a static method? Method is implicitly passed the object on which it was called. Alright, sure. Method is able to operate on data that is contained within the class. You should also add that methods in C++ are called member functions. Function is independent of any object and outside of any class. What? For Java and C#, there are only methods. For C, there are only functions. For C++, and Python, it would depend on whether or not you're in a class. Oh. Okay, so they're basically the same thing. In Java and C Sharp, they're only methods. So methods are functions in Java and C Sharp. Fair. Fair enough.
Is going to be the object that it is closer, okay, to the camera, okay, to the player. So a mouse down is going to be called automatically in this object if someone is touching with the left button and the mouse or the finger, if it is touching the object, okay? In order to work with on mouse down, it is compulsory that the game object has to have a collider, okay? Which is the situation right now, okay? So remember that we have added a collider, a sphere collider, to our prefabs. So on mouse down is going to work with our stones. And the only thing I'm going to do is very, very simple. The only thing I'm going to do is if I'm touching, somehow, if I'm clicking on the stone, I'm going to destroy it. Okay, so the only thing I have to do is this, to destroy the stone.
Really? Really? Is that actually it? That's a lot simpler than... Wait. Whoa, 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 whoa. But... Okay. No. No, that doesn't work. That does not work. You're joking me. You're joking me. You're joking. You're absolutely trolling the crap out of me. Watch, watch. What? It does. It works? Are you serious? Wait. Excuse me? How does it detect? But look, I could be clicking anywhere on the screen. Oh, fudge. That's not what I meant to do. This is actually fun. What the fudge? And I didn't do anything. Oh gosh, bro. Wait. Okay. I'm trying to think to myself how that works. Because if I click on the screen, what is telling the computer to not just destroy an object while I'm not hovering over it? You get what I'm saying? This is like fudging, what the fudge is it called? Aim Labs, kind of? Oh my brother, is so fast. This is like poor man's Aim Labs. Aim Labs is free, what the fudge? Okay, I'm I'm a little bit mind blown right now. Is this seriously 3 times speed? That seems slower now. But wait, you're telling me on mouse down? But, okay. On mouse down? Oh, okay. I'm still kind of confused. Like, okay, we're not. Oh. No. Okay. No, I understand. Okay. I get it now. I get it. Because this script is attached to the object, it only detects when the mouse clicks on that object. Okay. That makes sense. That makes more sense. For some reason, I was thinking this was like on the camera. This script was on the camera or on like the whole screen or something. But then there would have to be there would have to be more interaction there. So, because you can't just say destroy game object. I mean, it would destroy the camera if you did it. So wait, if you click, wait, it's actually more difficult to code for clicking to destroy a random stone than to just do this, right? Or am I tripping out? Okay, whatever. Either way, a very easy.
In a future video, we are going to add an explosion, okay? We are going to add some much more.
I guess I would have to add a sender and a receiver if I wanted a random stone to get destroyed whenever I click anywhere on the screen. Okay, I'm like hitting my mic. Okay, you can't hear it. Never mind.
Interesting visual effect, okay? But right now, this is the only thing I'm going to do. I'm going just to destroy the stone. So I'm going to save the script, and I'm going to see if it works. So I'm going to go to the game view. I'm going to activate maximize on play. So in this way, when we run, we are going to see almost full screen the game. Okay, so I'm going to try to click.
Oh my
to see.
gosh, what is
Okay,
that
yes,
FPS?
I'm destroying one of them. Okay, so I'm not very good playing, but anyway, you can see. Okay, you can see that it is working. Okay, it is working.
At least he's
I can
self-aware.
run it here. Maybe it's going to be much more clear. Yes. So as you can see, I'm destroying
Okay,
the
his
stones.
FPS
Okay,
is
I'm destroying the stones
still
using in this case the mouse.
kinda garbo a little bit. I don't know, is my FPS any better? Let's check. Yes, my FPS is far better. Why is my FPS so much better? Is it just his video settings or bing bong on the ring-a-rong ding dong? Okay, that one's gone. This is actually fun. I'm like semi-hyped for this, actually. Can I make like a full game in a week with the knowledge I have currently? I mean, obviously I'm gonna have to look some things up, but you know what I mean. You know what I mean. I may work on a super secret project. I may work on a super secret project within the next 2 weeks. Because this is a little bit easier than I thought. For some reason, I was just getting a little bit, I was just getting a little bit tired just from like, uh, doing the earlier lessons. But now that I'm actually like swinging into things. Now that I'm actually like making something, kind of, it seems a little bit easier. And like that script that he that pre-made one, that was like not very difficult, honestly. I mean, it was just a bunch of variables, and then he just like put them in, or they just put them in. Okay, hold up. I'm having too much fun. The best thing about having a super secret project is saying that you have a super secret project. You know, the thing is, no one knows what it is except me. That's what makes it a secret, not the fact that I, not the fact that people know that I'm making a super secret project. That's not what, like, like, it's still a secret if you don't tell people what it is, right? Like, you could say, like, if you say I have a secret, then that's not, then it's still a secret. You get it? It's like, yeah, I swear, if you literally tell someone that you have a secret, like, what the fudge? It's still a secret. They still don't know what the fudge you're talking about. You get it? You get what I'm saying? All right.
We are going to add some realism to our game.
Let's. Realism is what he meant to say. Bruh. Um. Yeah. Yeah. That's it.
And in order to do that, we are going to add an explosion when we destroy the stones. And then we are going to use what we call a particle system. A particle system is a very common effect we use whenever we want to simulate some natural effects, such as fire, dust, explosions, fireworks, and many more. The particle systems are systems that are based on the creation and destruction of particles.
Foggy.
And in order to create them, you need to understand how to create and destroy these particles with many, many parameters. And also you need some artistic skills, okay, in order
You know, my noise gate doesn't pick up my audio immediately. Like it just doesn't do it fast enough. I guess my computer's too slow. Wait. Oh, fudge. Oh, never mind. Never mind. I'm not going to use my good mic for streaming, like ever again, pretty much. Well, not for a long time at least. Yeah. Yeah, I mean, it cuts off the beginning of my words, this noise gate. But sorry, I got distracted.
to create
I
something
think I can finish this tonight. I can finish this before midnight
visually effective. Fortunately, we don't have to create our
because I don't want to have to do it tomorrow.
own particle systems because there are many collections of particle systems available. So in the asset store, you have thousands of particles you can import, okay? Remember that in the asset store, you have
True.
many assets and plugins and complements you can use for Unity. Another alternative is to use the ones prepared from Unity technologies, but they are available in the Learn section, resources. Here, for example, you have a particle pack in the current version of Unity I'm using. However, we are going to use one we have already prepared, so we don't have to import anything else. We have to just import a particle system we have prepared in order to create this explosion. So it is available in the course, so you have the link. It's just a Unity package. And the only thing we have to do in order to import this Unity package is to double click with Unity open. And the only thing we have to do is just to import it, okay? Okay, so...
Okay, fair enough. You know what's funny? So, apparently Wild Rift is made with Unity or Unreal. I don't know, actually. What engine does Wild Rift use? Yeah, okay. So Wild Rift is made with Unity, and apparently their production is like 100 times faster than League PC, just because Unity is so much better than like whatever rinky-dink piece of garbage engine that they like duct tape together back in 2009. Like, it's so garbage. It's so bad. It's so bad. It's just not, I guess, like, here's the thing. I don't think it would take them that long to remake League PC in Unity, right? Like, they already have all the assets. And yeah, I mean, that's like the most difficult part. They already have all the assets. They can just define like projectiles and stuff. They could have like a crowd control. What? A crowd control like class or something? I feel like it would be significantly easier. I mean, here's the thing. What if someone else remade League of Legends on it in Unity and then like saved Riot the work of remaking it in Unity? And then Riot just hires them on the spot just because it's like the person did their work for them. Yeah, I mean, what do they have? They have like a model maker or something. Syrup that or is it particle? Oh, it's particles. It's particles actually. Like a particle system, an in-house particle system that's like pretty garbo, yeah. Or it's like not, it's like bad, it's annoying to use. What I'm saying is that would be sick. I'm probably gonna look up League of Legends remade in Unity videos right after I end the stream because now I'm interested. But yeah, let's go to Bing Bang Bong. Um, okay, let me just actually
You have to do is
look
just
at what
import it.
he
Okay.
did. Oh, I'm just supposed to open it? Alrighty. Alrighty, alrighty. And then I import. Wow. Fact examples. Very cool. Now I can delete that because it's already in my gosh dang
Okay,
thing.
so here we have it. So the only thing we are going to be interested is in the
Actually,
prefab. Okay,
do
so
I
remember.
want to delete these? Okay, can I please? So I have... No. You know, I'll just save these. I'll save these. Restore. Just to save them later, I guess.
That the prefabs are going to be very useful for these kind of things. I'm going to be destroying the stone, so I'm going to instantiate from this prefab different explosions.
Yeah, I'll sort it later.
So this is the prefab I'm going to be using. So the idea is that when I destroy the stone, besides destroying the stone itself, I'm going to instantiate from this prefab. I'm going to create an instance of this prefab, and with that we are going to have our explosion. So the only thing I have to do is to change the script stone, where we destroy the stones, remember. So we are going to select the script stone, and here we are going to do something we have already done. We have to just create a public game object. So it's going to be accessible from the editor. And instead of dragging and dropping on a specific game object, what we are going to do is to drag and drop the prefab explosion we have imported. So I'm going to call it explosion. So the only thing I have to do here is to instantiate the explosion, and I'm going to instantiate the explosion before I destroy the game object, because I'm going to instantiate the explosion with the position of the transform. So this means that I'm going to console the game object properties. So I'm going to, before destroying the object, to get access to the properties of the object. So
yes,
I'm going to
makes
instantiate
sense.
Here before destroying, and I'm going to instantiate from stone.
That is so easy.
Okay, sorry from explosion. And I'm going to instantiate in the same position of the stone. So this is transform position. So here in the same position. And as a rotation, what I'm going to do is to do not rotate the particle system. So this means that I have to use the identity of the rotations. This is quaternion identity. Okay. So that's it.
Okay,
what? Do not rotate the particle system. So this means that I have to use the identity of the rotations. This is quaternion identity. Okay. So that's it.
Okay, I will read what that means later. Public game object. Public game object. I mean, this is surprisingly a lot easier than I thought it would be. Like once you get into it. I know I already said that, but whatever. Explosion. Okay, instantiate explosion. So what are the parameters for this? Instantiate. Okay, actually, if I do instantiate, can I? Oh, okay, it doesn't even let me do that. So the parameters here are original, object original. So what you want to instantiate. Then the position. Then the quaternion rotation. Can I get the gosh dang why, bro? Now if I do oh wow, I hate you. Oh gosh, I hate you. That is annoying as heck, bro. Why does it do that? And then, so what is this? Used to represent rotations? Now, why identity? The identity rotation. Read only. The identity of rotation. I don't know what that means. But it doesn't matter.
If we want to instantiate an explosion when we destroy the stone, the only thing we have to do is to create a new game object from the prefab and using instantiate as we have learned in previous videos. So the only thing I have to do now is to save this script and we can go back to Unity, and we haven't finished. Remember that we have modified the script. So now the three prefabs we have for stones, they are going to have this public game object, okay, explosion. So we have to drag and drop this prefab we have imported. So this prefab must be linked to the three prefabs of the stone. So we have the stones here. By double clicking, we have the properties of the first stone. So as you can see, we have here now explosion and it is now none, okay? Instead of dragging and dropping, what I'm going to do is to use this little circle we have here. If you click here, you're going to see that we are going to be able to select a game object, okay? So we can go to assets, and here we have a small explosion. So we can do a double click, and as you can see, we have selected the small explosion as the prefab we are going to instantiate in the script, okay? So remember that we have to do the same with the second one. So double click here, and we are going to do exactly the same. We have 3 prefabs. We have to select
Can I
the small
please?
explosion for the 3. So double click. And finally, the third one, double click, and we have to
What?
do exactly the same. Do asset, small explosion. Okay, now we can go back.
Really? My real question is, why the heck do I have to do that for all of them? Like, can't... Oh. Explosion. Because it's not defined. Alright. Never mind. Bang, 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 boom.
And theoretically speaking, it is prepared in order to instantiate the explosion when we destroy any of the 3 kinds of stones. So let's see the effect. So we can see.
No, the only
that,
problem with coughing.
Let's see if I'm good enough. If I destroy one of the stones, okay, we are going to see the effect, okay, the explosion, okay. Well, we can make the explosion bigger. We can.
Yeah, the only issue with coughing is that it like if I pull my mic back, it makes it so I have to readjust my mic again, and I hate it.
Change some of the parameters of the explosion. It's not difficult, so you can double click on the prefab explosion and explore in the inspector the different properties and try to investigate a bit how to do these kind of explosions, okay.
This guy really is pretty bad.
So as you can see, there's a side effect, okay, that it is that when we instantiate explosions, you see, they remain alive. So this is a problem because this means that if I'm playing a lot, okay, the game objects I'm creating from the prefab explosion, they remain alive. So this is going to be a problem, okay? So what we are going to do right now is to change the script we have already modified in order to be sure that these small explosions are also destroyed. So let's go again to Visual Studio, and we are going to try to do something here. Well, one possibility we have is, well, you know that instantiate is going to return the game object created, okay? So instantiate creates an object, a game object, and returns the reference of this game object. So we can use destroy, okay? So this means that I'm destroying the game object and created in instantiate. If I leave the thing as it is, well, I'm not doing anything interesting. I create the object in instantiate and I'm destroying the object immediately. So we are not going to be the effect. We are not going to be able to see the effect, okay? So we are not going to see the effect, the particle system, because I'm destroying it immediately. But there's an option in destroy, which is a second parameter in the destroy. So we can go here, and the second parameter is the time to delay before destroying the object, okay? So I can add a delay, for example, a couple of seconds. So I'm saying that I'm instantiating the explosion, instantiate returns the game object, and destroy is going to destroy this game object, but it's going to wait 2 seconds in order to do that, okay? So
that's interesting. Yeah. You know, they've made a pretty good thing here. They've made a pretty good thing here. If I do 2.0, it's going to be the same. Yes.
we're going to see the effect.
Good on
okay?
you, people
So
that made Unity and Unreal. Good on you, honestly. I mean, what Unity's like, or Unity and Unreal are industry standard now, right? Except, I mean, unless you have like CryEngine, unless there's like CryEngine or some proprietary engine, which could be better. Who knows? We don't know. We don't know if it's better. Like the Call of Duty engine, I don't know what that is called.
Is going to do the explosion, and after 2 seconds it's going to be destroyed. So we are not going to have this instance of explosion.
Oh, and then there's like source. There's like source 2, source 3. I don't know if they have 3 yet though.
Active in our game. So now we are going to save this, and we are going to go back to Unity, and we are going to see if this is the thing that happens, okay? So we are going to destroy, we are going to destroy, we are going to destroy. So you can see that after 2 seconds, the small explosion disappears, okay? So in this way, we are having the effect, and the effect is removed. The game object we create with the explosion is removed. Not very good playing with the game. Okay, but you can see that the number of active objects in the scene is limited. Okay, so because I'm destroying the stones and also I'm destroying the explosion.
Nice.
Okay, we
Honestly, I'm glad he's teaching optimization like right now.
are creating and
I
destroying.
mean, I guess it would kind of be bad if he wasn't teaching optimization. So, never mind.
Stones, but we are not tracking this information, so we don't know exactly what's going on. And it is going to be very important to know what's going on in order to implement a game mechanic. So we have, of course, to have an objective for the player. So what I'm going to do now is just that. I'm going to be able to know exactly how many stones I have thrown, and also how many I'm destroying. Okay, so this is the idea. In order to do that, in order to manage this global information of the game, we have some possibilities. One possibility is to use a singleton, a pattern, a very well-known design pattern. But in order to make the things simple, we are going to use another way, which is to create static information. Okay, so static information, as we are going to see.
Singleton. Why do I keep checking, bro? Singleton. Is this not, does this not mean idiot? Oh, simpleton. Simpleton is idiot. Got it. A set which contains exactly one element. Got it. They're the same. Never mind. And it's right there too. Great.
Means that we are going to create a static class with static attributes. And one of the characteristics of static attributes in C# and also in many object-oriented programming languages is that we are going to have a unique instance of these attributes. So we are not going to have several instances. We are not going to instantiate objects from this class, this static class. So this information is going to be global and
Hold. We're gonna create, another way is to create static information. Okay, sure. Static class with static attributes, which is a regular class. There are no non-static classes, right? That'd be kind of not, right? Oh, there are non-static classes. Like, there are like subclasses which are non-static. I think.
accessible, in this case, from
Whatever.
all the scripts of the game. Okay, so this is what I'm going to do. Okay, I'm going to go to scripts. And as a matter of fact, what I'm going to create is not strictly speaking as a script, because as you're going to see, we are not going to attach this script to any game object, because it's not going to be a class that derives from monobehavior. It's going to be a static class. And Unity is going to know that for this static class, it has to allocate memory for the static attributes. And this memory is going to be, these attributes are going to be unique, okay? So we are going to have only one instance of them. And you're going to see that it is going to be very easy to get access to this global information from any script. So I'm going to create this class. It is going to be called generally Game Manager or something like that, okay? I'm going to call it Game Manager, as you can see.
Hold.
From instance
What?
of them. So I'm going to create this class. It is going to be called generally Game Manager or something like that, okay? I'm going to call it Game Manager, as you can see. Even the icon is a bit different because of the name, okay? So I'm going to double click.
Okay. Okay. Imagine your name being so awesome that it changes how you look. I need to change the gosh dang. Yeah, I need to change the gosh dang font size and everything on this. I really need to customize a lot of things. Like um, this default script here, or this script template is garbo. It's garbo, bro. It's garbo. I don't know why I'm acting like an Italian, but whatever.
And as you're going to see, we don't need any using. And the reason is because we are not going to inherit from mono behavior, okay? So it's going to be what we call a static class. So we are going to put a static here, which means that with this static means that everything inside this game manager must be static, okay? And what we are going to put here is a public static int. So I'm going to add an attribute here, which is going to be static. Again, this means that this attribute is going to be unique, only one instance. The memory of it is going to be taken when we run the game. And because it's public, it's going to be accessible from any script, okay? I'm going to call it, for example,
Okay, here's my real question. Couldn't you just make a variable in the don't? No. No. Never mind. Couldn't you just okay. Or a script. Yeah, couldn't you just make a variable in the stone script? But no, you can't do that. Couldn't you just make a variable in the camera? Or can you just make a script, put it on the camera, make a variable inside that script to count the number of stones that are destroyed by the click or not? Whatever. It's a good question, but I'm not going to get the answer right now.
current number stones thrown, and I'm going to initialize it to 0, okay? So the objective of this attribute is to count how many stones the game has thrown, okay? And I'm going to add another one, static int current number destroyed stones, that it is going also to be 0, okay? So this is the only thing we are going to have in this class, okay? As you can see, we are not going to attach this class to any game object because it's not a script, okay? As we have been doing in the previous examples. So this is global information, global memory. Only one instance of these attributes is going to be allocated when we run the game, and they are going to be, because they are public, accessible from any script. The only thing we have to do is, in order to get access to them, we need to use the name of the class. So as we are going to see, we need to get access to this information using game manager dot and the name of the attribute. So we can save this, okay? And we can go now to the different scripts that are going to use this information. So how we can properly
this
update
is it?
the
This
these
is all
variables,
we need?
it's very simple. Whenever we create a new stone,
right.
we will have to increase in 1 unit the number of current stones, okay? So for example here, the only thing I have to do is to get access to game manager, and in game manager, current number stones thrown, just to increase it, plus plus, okay? Or we can do, as you know, we can do just current number stones thrown equal to current number stones thrown plus 1, okay? But this is the most compact way to do that, okay?
Yes.
So with that, we are increasing the number of stones we are throwing. So we can visualize as you're going.
Oh. I could have just done minus. I could have just done double minus, I forgot. So, wait, what did I even do that for? Oh, yeah, I did that for the lives. Never mind. So, cool, I guess. Probably never gonna need that again. And then main loop. And then add where? Add I enumerator?
going to see that current, or we can do manager to do 1 unit, the number is very simple. Whenever we create a new stone, we will have to increase in 1 unit.
Oh, true. Yeah. Yeah, true. Whenever you create a new stone. Correct. Dot current number stones thrown.
Unit the number of current stones, okay? So, okay, or we can do it, we can equal to current number of stones thrown plus 1, okay? But this is the most compact way to do that, okay? So with that, we are increasing the number of stones we are throwing. So we can visualize, as you are going to see in future videos, we are going to visualize this information. So we will be able also to have some kind of game mechanics, an objective, okay? Okay, this is going to be very important. So now in the script stone, whenever I destroy also a stone, what I'm going to do is to get access to Get Manager, and in this case, the number of destroyed stones, how good I am as a player, is going also to be increased, okay?
Yes. But this only works because it's global. Got it. Got it. Okay. Inconsistent line endings. What is this? I don't think it matters. Okay, update available. Don't care right now. Thank you. Properties. That should be fine. That should be fine.
So that's it. This is the only thing I have to do, and this is the only thing we are going to do in this video, just to be sure that we are controlling somehow the actions of the player, okay, and the evolution of the game. So we are counting the number of stones we are throwing, and we are also counting the number of stones we are destroying. Very soon you are going to see that this information is going to be important for the game mechanics, and of course we are going to display this information in the screen.
Yeah, let me actually go into this and then print this. And then just do the same thing. Takes like 2 seconds. That's not what I meant to do. Yeah, that should work. Let's remove the maximize on play. Go look at the console. Okay. Is it not working? So if I go up, oh, okay. Got it. 1, 1, 2, 3, 2, 3. Yeah, all right. Maybe I could do destroyed stones. And then we just don't, nothing fancy, just bing, bang, boom. Beautiful. So these are the ones thrown, these are the ones destroyed. Yeah, honestly, definitely good. I'll just leave it, whatever.
Let's visualize the information we are tracking. And we are going to use, for the very first time, the graphic user interface tools we have in Unity. These tools are really, really very powerful, and we can, with them, create any kind of interface.
They're
It has many
powerful.
possibilities. We're going to see
Power.
just the very basic elements
Power.
of this collection of powerful tools. In order to do that, I'm going to visualize as a text how many stones I have thrown and how many I have destroyed. Okay, so I'm going to basically to visualize a couple of texts. And I'm going to do that in a way we call HUD, head-up display. So this is the kind of elements that are overlaid to our game, no matter what the camera is looking at. Okay, so this is these kind of elements that are always visible during the game, and they are just as an additional layer to the screen. Okay, so in order to do that, we have to use a very important element, which is called the canvas. Okay, so we need to add a canvas. The canvas is going to be the
Okay, I'm like zoning a little bit. Okay, any kind of interface. Visualize the information we're tracking. We're gonna use, for the very first time, the graphic user interface. Okay, text, yep.
And I'm going to do that in a way we call HUD, head-up display. So this is the kind of elements that are overlaid to our game, no matter what the camera is looking at. Okay, so this is these kind of elements that are always visible during the game, and they are just as an additional layer to the screen. Okay, so in order to do that, we have to use a very important element, which is called the canvas. Okay, so we need to add a canvas. The canvas is going to be the parent of all the user elements, user interface elements we are going to have in our
All right.
game. So we need at least one canvas. Okay, we can have several, but in this case we are going to have one canvas. As you can see with the canvas, we have several we are going to have in our game. So we need at least one canvas. Okay, we can have in inspector many options, many possibilities. So I'm going to keep this one by default. This is screen space overlay. This is the HUD. Okay, so this is what we are going to do in our case. We want to have this canvas on top of whatever we are visualizing with our camera in the game. But there are other options, okay, that allows us to integrate this canvas into the real 3D space. So this means that we can have the buttons, the sliders, or whatever at any position of our environment. So we will be able, the player will be able to interact with them in the 3D world. But I'm going to keep it overlay. This is the kind of interface we are interested in right now. What we are going to change is here, the scale mode. Instead of constant pixel size, we are going to use scale with screen size, something quite common, which means that our controls, our user interface elements are going to change in size depending on the size of the screen. Okay, this is going to be very convenient in many games. Okay, so now we have this canvas in our game.
All right. Canvas. Create new UI. Canvas. Event system. Why is this here? Where did I get this? Event system. Where did I get this? What even is this? Event system. Is that on his? It is. What? Oh. I see. It just created a game object for me to have the, no. Wait, no. I don't know what that is.
The only thing we have is, okay? So we need to add a canvas are really, really very powerful.
When did
And
this
all of
get
them, they must be
added?
children of the canvas, okay? This is here, the scale mode, instead of constant pixel size, we are going to use
Whatever.
scale width screen size, something quite common, which means that our controls, our user interface elements are going to change in size depending on the size of the screen. Okay, this is going to be very convenient in many games, okay? Okay, so now we have this canvas in our game. The only thing we have to do now is to create the different controls we want to have in our interface. And all of them, they must be children of the canvas, okay? In this case, I'm going to have only one canvas, but any interface element is going to be a child of a canvas. In order to do that, I can click with the right button in the canvas, and in the UI section, I can select any of the controls we can have by default. Of course, there are libraries of additional controls we can have in our games, and of course, we can create our own controls. In this case, we are going to use just text. So as you can see, we have a text element that it is a child of the canvas, okay?
All right.
So because we are going to display two informations, we are going again to select the canvas, and again with the right button, I'm going to add another one. It is going to be another text. The very first thing I'm going to do is to change the names. Instead of text, I'm going to put, for example, text thrown. And for the second one, I'm going to use, for example, text destroyed.
Simple enough. Text thrown. Text destroyed.
Okay. So these names have no additional effect, just are the name of the, in this case, the text controls. Now we have to decide where we want these elements regarding to my parent, in this case, the canvas. So we have in Unity many options, and fortunately we have a collection of presets. So it is going to be very easy to say which is going to be the position of these controls regarding or relative to my parent. In this case, I'm interested in put them in the top left corner. So this is what I'm going to change right now. By default, as you can see, they are anchored into the center. But we can change these anchors. We can say what we want to do. We can anchor these elements to one of the corners or to one of the sides. Even we can, if we want, we can stretch them to the width or the height of the parent. In this case, the parent is the canvas. Where we can do that? Very simple. Here in this button we have here, we can click and we can see all the presets that are available in order to specify where exactly I want to anchor my control. So in this case, I want to put them in the top left corner, whatever what happens with the canvas. Okay, so this means that if the screen size changes, I want to be always anchored in the top left corner. So in order to do that, we are going to use the one we have here. As you can see, we can anchor in one of the corners, or we can anchor in the sides or in the center, or we can make a combination. Even we can stretch horizontally or stretch vertically or stretch the element horizontally and vertically. Okay, so it's not difficult to understand how they work. What we are going to do is to use these two options we have here. We are going to use Shift and Alt, which means that we are not only going to anchor the element into the corner, that with the Alt means that we are also going to move the element into the corner. And we are going also to use Shift in order to change also the pivot of the element to the same position, just in case if we are interested in scaling it or we are interested in rotating it. So the pivot is going to be the point where this control is going to use in order to rotate and scale. So I'm going to use Shift and Alt, okay, and I'm going to select this one, okay. I have to do this for the two elements, for text destroyed, and also I select text thrown, and again I click here, and with Shift and Alt I'm going to select the corner, okay, the top left corner, because I want this information there, okay, I want this information there in this corner. They are texts, so as text we can change the text, we can change the font, we can change the font style, we can import fonts from outside and we can use them, okay. We can change the alignment and we can do the normal things we can do with text, okay. What I'm going to do now is to move, in this case, the text destroyed. I'm going to, with the translation tool, I'm going to move it under the other one, okay? So I'm going to have them, okay?
Sure. This is way too large. Why is this so large? What is, okay. Move to view. No. Align with view. Align view to selected. Toggle active state. I knew what that was gonna do. Why didn't I? Thank you. I'm gonna put destroyed in the top left. Shift. Oh, I have to hold it down. Okay. Then I'm gonna do this one. Top right. Wow.
In the top left corner, but one after the other. If we go to the game view, as you can see, this is the result. And because they are anchored to the top left, no matter what I do, okay, with the screen size, they are always going to be there, okay? So this is the consequence, okay? So the anchoring system we use in Unity is very useful. So now the only thing I have to do right now is how we can print this information into these controls I have created. And of course, in order to do that, we have to create a script. So we go to the scripts, and we are going to create another script we are going to call interface stone. Okay, interface stone. This script is the one we are going to use. So we double click on it, and let's see in which way we can interact with these controls we have right now in the scene. Before doing anything, we need another using, because I'm going to be using elements of the interface. It is called Unity UI, okay? So what I'm going to do is a technique you already are familiar with. We are going to create a couple of public game objects that I'm going to attach with the two controls we have right now in the canvas. So in the canvas, we have right now two texts. So the script needs to know the references of these game objects. These texts are game objects, so the script needs to know the exact reference of these elements. And we are going to do it as usual with drag and drop. So I need to make them public, and they are called text, okay? So they are of the type text. And we are going to call it, for example, text thrown. And the other one I'm going to call it, for example, text destroyed. Okay. So in the editor, I'm going to drag and drop the actual controls I have created as children.
Okay. I'm zoning a little bit, so I might just get off after this video. I'll just do interface. Hey, import? No? Okay, and then public text is apparently a class? Sure. That was weird. Text thrown, text destroyed. Text destroyed.
Children of the canvas. So when this script runs, text thrown and text destroyed are going to be the reference of these elements, okay? So right now, the only thing I have to do is to really put information inside these texts. The information we have in the static class, and this is going to be very easy. We can go to the update because we have to update this information every frame. And we are going to get access to text thrown. And inside that, we have an attribute, it is called text, that it is the actual text we have to put.
There you go,
of the type
bro.
string. So what I'm going to do is to put something such as, for example, number of stones. And then I'm going to concatenate the information we have in the game manager, number of stones thrown, okay? So in this way, I'm going to be displaying this information in this control we have in the screen. And I'm going to do, of course, the same thing with text destroyed. In the field text, we are going to put number, or we can say just destroyed, how many we have destroyed. And again, this information is in the game manager, current destroyed stones, okay? So as you can see, to update information of these controls is not very difficult. We have a field, it is called text, where we can put a string with this information. So we can save this script. And now we have again to decide, this is a normal script, we have to decide what game object in the scene is going to have this script, okay? So we have several options again. We can create an empty game object and call it, for example, interface, and this empty game object is going to have this script. Or we can use the camera, or which is alive all the time, or we can use, and this is what I'm going to do, the canvas, okay? So you can use the canvas itself, but it is of course going to be present all the active, all the execution of the scene. We can use it as the one that
Equals. All right. Sorry, no, this is stones thrown. Game manager dot thrown. I love that. I love how it doesn't. Stones destroyed.
save this script. And now we have again to decide, this is a normal script, we have to decide what game object in the scene is going to have this script, okay? So we have several options again. We can create an empty game object and call it canvas already. And text thrown and text destroyed are these public game object attributes we have in the script, and of course they are none. So the only thing I have to do is to make the connection. I have to drag and drop, okay?
Huh. Okay.
And to drag and drop again for the second one. Okay, so this means that if we have done everything in the correct way, it has to work. So we can see that the number of stones is 0, now is 1, 2, 3, 4. We are counting the number of stones we are throwing, and if we try to destroy them, you can see that this number of destroyed stones is
I see.
increased as well. So now we have learned how easy it is to have a head-up interface, a HUD interface in Unity.
Adding scenes. Yeah, I'll do this tomorrow. All right. Well, that's it for this stream, guys. Thanks so much for joining me. Thank you for spending your most valuable resource, the time in your life, on watching my stream. And have a good one.